All right, so we're interested in an interval question. So I have this equation which says log of x squared minus 1 times y double prime plus 1 over sine of x y prime plus sine of the square root of x y is the absolute value of x. And I have initial conditions, which are y of pi over 2 is 1. Oops, not is 1, is 0. And y prime at pi over 2 is 1. And they're asking me what interval could this be solved on? Right? So when I'm looking at an interval for a, what kind of beast is this?
Second order.
Species, second order. And it is linear.
Non-homogeneous.
It is definitely non-homogeneous.
Non-constant coefficient.
And it has not constant coefficients. Probably should say variable coefficients, shouldn't I?
Sure.
But the idea at least is that it's not constant, right? Really, that's kind of a note about which technique I'm allowed to apply, right? Not a hard and fast thing about classification. Okay. Anything else?
Differential equation.
And it is still a differential equation. Okay. All right. So I think of interest to me, right? When can I solve this thing? What do I need? Like, oops. In order to solve this, what am I going to need at the very least?
Well, I would put it kind of in its standard form.
Okay.
And divide that first coefficient through.
Okay. So you want to divide by log of x squared minus 1?
Mm-hmm.
So you got 1 over the sine of x divide, I'm putting this down here. Okay, so you divide through by log of x squared, and you get some stuff, right? Oh my god. Okay, so you get all this junk, right? And then, wait, I just divided by something, right?
Mm-hmm.
What should I be worried about when I divide by something?
Zero.
Zeros.
Yeah, I want to know when that was 0, right?
Mm-hmm.
Why would that be interesting?
Because we need the interval.
Yeah.
Yeah,
All of
also because if this part, right,
Mhm.
is 0, then you're not talking about one of these beasts anymore, right? It's no longer second order, it's first order there. You guys see that? So I definitely need to worry about when is log of x squared minus 1 0. First concern. So,
No, sorry.
30 minus 1?
so I think you
Oh,
e
the whole
both
thing.
sides,
Right.
right?
Mhm.
So you get x squared minus 1 is e to the 0, which is 1. And then you add 1 to both sides, so you get x squared is 2.
So x is plus or minus square root of 2.
So x is plus or minus the square root of 2. Okay, so over here, I'm going to make a big ass number line. And on my big ass number line, I'm going to put what 3 points are so far interesting on my number line.
Zero.
Plus or minus.
Root 2.
Why is 0 interesting? Okay,
Well, just
sure.
consider.
Yeah.
Just a B somewhere?
Yeah.
Okay, so I put 0 on this just to center me up,
It has
orient myself.
it has-
Positives this way. Right? Should I just screw with your heads and put positive? Okay, so then what else is interesting?
It has to contain pi over 2.
Okay, so I need pi over 2 somewhere. Pi over 2 is traditionally on this side. Right? So, okay, so here's my pi over 2. That's kind of the interestingest bit, right? Like, that's definitely going to center up my interval, probably. Well, or at least be a part of my interval, right?
So x is plus or minus root 2.
Sin x can be pi.
Oh, yeah, so hang on. Chill. So I have plus or minus root 2, right? Those are also going to be interesting, and those would break things, right? So I need to put those on here as slices. So minus root 2 might be, oh, how does root 2 compare to pi over 2?
It's a little tiny bit smaller.
How'd you get that?
1.414 versus 1.7.
Okay, so you looked at pi over 2 and you recalled that that was 1.41
Yeah.
or something. And then you looked at pi over 2 and thought to yourself, well, pi is about 3. And then when you divide by 2, you get like
1.5.
a bit bigger than 1.5. Okay, so I know at the very least I have a badness. Damn it. Red mark. I have a badness at square root of 2. Oops. Of course, I erased my pi over 2. And then I also have a badness at minus root 2. See that? So at the very least, my interval is going to have to end at square root of 2. You guys all see that? So first guess, square root of 2 is the start of your interval. You guys see that? Okay. Now you might do what Tony was doing, and you might say, okay, what other thing should I be worried about?
Sin x.
Yeah, I should also be worried about dividing by 0 in other ways. Oh, dang it. Sorry, Ken.
I want those assist.
So I should be worried about sin x, right? Because I'm dividing by it, I should be wondering, when is sin x equal to 0? Let's see. So for that one, I probably get a picture of sin x out of my head. It looks like this. Let's see. So it's 0 at 0.
And then
0,
integer multiples
0,
of pi.
pi, 2 pi.
Okay, so 0, and then pi is going to be over here somewhere, right? And then there's probably a whole bunch more of those. And by probably, I mean there are actually a whole bunch more of those. But I only care about these two because those are the two on opposite sides. And really, I only actually even care about pi, right? Because pi was the furthest right I could get. Okay, then what else?
The sine squared of x can't be 0. Or sorry, can't be undefined.
Yeah, this guy can't be undefined, right? So I need sine of the square root of x to be continuous, right?
So x must be greater than 0.
Continuous and real.
Yeah, so continuous and real, right? So where is the square root of x?
Greater than or equal to 0.
Bigger than or equal to 0? So that would start me at 0 again, right? So I have,
It has to be greater than by 1 over sin x.
sorry, say again?
0 can, x cannot equal 0 by 1 over sin x because that would make it 0.
Yeah. So this part, right, isn't going to happen. Specifically, it has to be strictly greater than 0 because sine of x can't be 0.
We can also, the natural log is undefined for negative numbers also.
Oh, yeah, so I should have been worried about when is the natural log 0 or when is it undefined, right? So now I should chase down when is the log of x undefined. I originally threw this in here, right, because I was worried about dividing by it. But I should also worry about when it's undefined. So I need x squared minus 1 to be bigger than 0.
So x squared must be bigger than 1, so x must be
Yeah, so I'd probably do that this way. I'd take x squared, shift it down a unit, and say, okay, so goodness is happening when I'm bigger than 1 or smaller than -1. You guys see that? So the smaller than -1 stuff would be okay, or the bigger than +1 stuff would be okay. Where are those bets? Yeah, so those would be more slices at -1 and +1. And I know that I wouldn't even be allowed anything in between there. So I couldn't have this stuff, right? From my square root thing, I know I can't have any of this stuff. You guys see that? Okay, so what's the best interval I could hope for here?
Root 2 pi.
From root 2 to pi, I think.
Yeah, non-inclusive.
Yeah, and then why can't you include those?
That's
It's
the
fine.
At least at pi, right? You're dividing by 0
Yeah.
there, right? Not allowed. How about the square root of 2? Where did that one come from? Oh, that one also
Zero.
came from dividing by 0. You're not allowed that one either. So, from square root of 2 to pi is the best you could hope for.
That doesn't include your initial conditions.
Yeah, so the initial conditions were pegged at this pi over 2, right? And I can't go past pi because in this part, there wasn't any division by 0. For me to get past pi, I'd have to divide by 0 in the process, right? So there's some solution over there, but I don't know anything about the initial conditions over here telling me what happens over there because you can't step across that gap.
So do we need these initial conditions to solve this? What can we do without it?
Like the
So-
0 in the 1 don't matter, right?
These guys?
Yeah.
No. Yeah, you don't need those. So for this, right, what's the best I could hope for? Like, what's the biggest interval? It doesn't matter what the values are, but it does matter where they are. You guys see that?
They have to be in your interval.
Yeah, this value, right, at which you're given
Oh,
the
has to
starting
be
position
in.
in philosophy,
Okay.
has to be in the interval. Because otherwise you don't know what's up.
That makes sense.
Right, so if this was 3 pi over 2, right, then the best interval I could hope for would go from pi up to
2 pi.
2 pi. That's where my next problem is. I didn't mark that one, but that's one of these.
Yeah.
You guys see that?
That'd be meaner.
That would be meaner. Okay, cool with this? So these questions are a little bit rough, but basically they amount to like a whole bunch of pre-calculus problems that you have to do kind of simultaneously and not screw any of them up. Cool?
Of the categories that you put up of difficulty, what would you for this one?
I would call this question probably someplace between the C and B level.
Okay.
Because I would call it C level if there were only 2 of these parts, or 3 maybe. But this one has probably 4 different considerations. And you have to get all 4 of them, right? So I would call this hard C, low B. That kind of make sense?
Basics to good.
Yeah, basics to good, right? Basics, like, do you know what the problems would be? Good. Do you actually have all of the arithmetic skills or all of the algebra skills to get all of that together and not lose anything? And that's really a question more about organization than it is about facility, right?